Have you ever stopped to think about your sense of smell? I mean, really think about it. Beyond just, catching the coffee brewing or, uh-oh, did I leave the oven on?
Right.
What if it's doing something way deeper, something really tangled up with your own internal body chemistry without you even noticing?
And that's exactly the fascinating question you brought to the table for this deep dive.
Yeah.
Could our olfactory nerves, the ones we use for smelling, actually have evolved to sense our own internal endocrine stuff?
Stuff coming specifically from the pituitary gland, maybe, to help, stabilize those really important neuroendocrine feedback loops.
Exactly. Basically, tuning your body's own hormonal systems. Yeah. It's a really original and pretty mind-bending idea.
It really is. It takes something we think is pretty straightforward smelling and twists it. Now, we should probably say right off the bat, direct smoking gun proof for this exact thing in humans. It's not really there yet.
That's true. We need to be clear about that.
But the journey we're taking today, it uncovers some really fascinating hints, some indirect links, and some evolutionary clues that suggest things are way more connected than you'd probably guess.
Absolutely. So our mission here is to kind of map out these surprising connections and explore how your sense of smell might just be this secret agent operating inside your own body.
Okay, where do we start? The olfactory nerve itself.
Yeah, let's dig into that. Cranial nervite. It's the first of the 12 big ones, and honestly, it's a bit of a weirdo compared to the others.
Oh, weirdo. How so? I mean, what makes it stand out?
Well, the big thing is how it's wired into the brain. Unlike pretty much all your other senses, sight, hearing, touch, the olfactory nerve signals, they don't make that pit stop at the thalamus before heading to the higher brain areas, the cortex.
Ah, okay, so it skips the main relay station.
It totally bypasses it. It's like it has this VIP backstage pass directly into some really critical brain zones.
Which zones are we talking about?
We're talking direct lines to parts of the limbic system, like the medial amygdala that's big for emotional processing and also hypothalamic regions. Think the preoptic area, the ventromedial hypothalamus.
Okay, hold on. Those sound important. Hypothalamus. That's like the body's thermostat and hormone control center, right?
Precisely. These areas are absolute ground control for managing emotions, stress responses, reproduction, all that core hormonal regulation stuff.
But hang on, the smell receptors, they're up in the nose, right?
Yeah.
Exposed to the outside air. How could they possibly sense something internal, like hormones, from the pituitary deep inside your head? Seems like a mismatch.
It does seem counterintuitive, you're right. But that's part of what's so unique. While the sensory endings are in the nose, their connections, their central processes, they dive straight into the central nervous system.
So it's like an open door, in a way.
Kind of. It creates this direct gateway. Perfectly set up for external smells, obviously, but that structure. It opens the possibility for picking up on internal chemical signals, too. This direct, unfiltered access makes it, well, uniquely positioned for maybe a bigger role than just smelling roses or, burnt toast.
Okay, intriguing. But back to that direct evidence point, you said it's not there for humans sensing pituitary hormones directly via smell.
Correct. No direct proof of that specific feedback loop. If you're asking, do my olfactory nerves smell my pituitary hormones? The answer, as far as we know, is no.
Right. Got it. So what does that leave us? Is the idea just dead in the water?
Not at all. This is where we pivot to the indirect evidence, and honestly, this stuff is fascinating in its own right. It shows just how deeply, deeply intertwined these olfactory and endocrine systems really are. Maybe they even kind of grew up together, evolutionarily speaking.
Okay, I'm listening. What's the first piece of this indirect puzzle?
All right, one really surprising angle involves your cerebrospinal fluid, the CSF, the fluid cushioning your brain and spinal cord.
Yeah.
Well, get this. There's evidence suggesting CSF can actually flow out from deep brain areas, like the third ventricle, and travel along the pathways of the olfactory nerves through that bony plate at the top of your nose, the cribriform plate, and potentially reach the nasal lining itself.
Wait. So the fluid bathing my brain could physically reach the area where my smell receptors are?
It appears so. Research points to this possibility. Now, again, this probably isn't smelling in the way we normally think about it. It's not like you'd perceive an odor.
Okay, because that would be weird.
Definitely weird. But it suggests that maybe neurochemicals floating in the CSF signals from deep within the brain could potentially influence those olfactory structures. Some researchers think it might be more like a signal clearance pathway, or maybe even a sampling interface.
Like the nose is kind of checking the brain's chemical weather report.
That's one way to think about it, yeah. A very subtle background check. It hints at a physical link we don't normally consider.
Wow. Okay. What else points towards this connection?
Well, beyond the fluid, we have to look at that wiring again. The really tight connections, what we call olfactory limbic hypothalamic coupling.
Right, you mentioned the amygdala and hypothalamus earlier.
Exactly. The olfactory system isn't just sending signals to some isolated smell center. It's plugged directly into the amygdala, your emotion hub, and the bed nucleus of the stria terminalis, which is critical for stress.
So smells can directly tweak your emotional state and stress levels? We kind of know that intuitively.
We do. And importantly, it's also wired into that preoptic area and medial hypothalamus. Those are the absolute command centers for reproduction and hormones. We see this really clearly in animal studies, especially with pheromones.
Ah, pheromones, those chemical signals animals use to communicate, right?
Right. In many animals, specific smells, pheromones detected by the olfactory system, sometimes a specialized part called the VNO, or accessory olfactory system, can directly trigger hormonal cascades and behavioral changes. They could literally entrain the endocrine system.
But humans don't really have a working VNO, do they? Or it's vestigial?
Mostly vestigial or maybe absent in adults, yes. But the main olfactory system still has those direct links, so the principle remains. External smells can influence your internal hormones. Think about how certain scents can be relaxing or stimulating or even trigger memories tied to strong hormonal states.
Okay, so information flows from smell to hormones. That makes sense. But what about the other way? You mentioned hormones influencing smell.
Yes, and this is a really well-established connection. It's called endocrine modulation of olfaction. Your hormones absolutely change how sensitive you are to smells and how well you can tell them apart.
Okay, like how things smell different at certain times.
Exactly. Think about estrogen, progesterone, cortisol. These major hormones fluctuate, and they demonstrably affect our sense of smell. It's very common during the menstrual cycle, for instance, or during pregnancy.
Yeah, pregnant women often report becoming super sensitive to smells or suddenly hating smells they used to like.
Precisely. And stress, which involves cortisol, can also alter your olfactory perception. So while your olfactory system might not be directly detecting the hormones themselves,
It's definitely being tuned by them, like the hormones are adjusting the sensitivity dial on the smell detector.
you got it. It's a significant feedback loop, even if it's not direct chemical sensing in that one direction. Hormones shape smell, and smell can shape hormones. They're constantly talking to each other.
Okay, this is weaving a much richer picture. Let's zoom out a bit. What about evolution? Where does this idea of sensing yourself fit in?
Well, if you go way back to really simple organisms like invertebrates, their chemical sensing systems were likely much more unified. They didn't necessarily have distinct systems for what's outside me versus what's inside me.
So it was all just chemical information, regardless of source.
Pretty much. It was all just chemosensation. And there's reason to believe that the tissues that give rise to our external olfactory sensors and internal chemoreceptors, sensors monitoring our internal state, might have actually evolved from common ancestral tissues, these things called placental tissues in early development.
Placodes.
Now,
Okay, so the building blocks for internal and external chemical sensors were maybe the same originally.
it's a strong possibility.
Yeah.
Which means that this idea of internal olfaction, the ability to sense your own body's chemical environment, might have been present in very primitive forms. Think ancient creatures like sea squirts or amphioxus.
Wow.
And then, as life got more complex, maybe these pathways specialized. One branch focused outward, becoming our sense of smell for the external world. The other focused inward, becoming the internal receptors that manage homeostasis, our internal balance.
But, and this is the cool bit from the sources, right? What if that separation wasn't totally complete?
Exactly. This leads to that really provocative thought. What if our modern olfactory structures, even today, still hold on to some kind of remnant, a vestigial echo maybe, a symbolic role in sensing the cells?
Like a molecular echo of that ancient time when internal and external chemical sensing were one and the same?
That's the hypothetical interpretation, yeah. It's speculative, of course, but compelling. So maybe the olfactory system isn't directly smelling the pituitary gland's hormones.
But it's playing some other role.
Perhaps it acts more like a modulator. It's not detecting the specific hormone signal, but it's helping to set the stage, influencing neuroendocrine readiness based on everything else it knows, your memories, your experiences, the current environmental cues.
So it's bridging the gap,
Yeah.
connecting your inner world, the outer world, and how your body should respond.
That's the idea. It acts as this integrator, subtly adjusting your internal settings based on a much wider context than just hormone levels alone, like a quiet, ancient part of your brain whispering adjustments based on the whole picture.
Okay, so wrapping this all up then, the original question, can we literally smell our pituitary hormones? Probably not directly, based on what we know now.
Correct, the direct evidence isn't there for that specific mechanism.
But this deep dive has shown, wow, an incredibly tangled, intertwined relationship between your sense of smell and your internal hormonal world. Way, way more complex than just detecting smells outside.
Absolutely. It's far from simple detection. The connections are deep, they're bidirectional, and potentially rooted in some very ancient evolutionary history.
It leaves you wondering, doesn't it?
It really does. Could your sense of smell be quietly nudging your moods, shaping your stress responses, maybe even influencing reproductive cycles in ways we're only just starting to glimpse?
Acting like the subtle, ancient chemical whisperer inside us all.
That's the lingering thought. A hidden layer of regulation mediated by a sense we often just take for granted.
Definitely gives you something to ponder next time you, stop and smell the roses. Or anything else, for that matter. There's clearly more going on up there than we think.